Yesterday, it should not take that long. All right, so it's super, super quick. So the rest of the class period, you can work on your homework. So I know you didn't have a whole lot of time yesterday, but hopefully after today, you should have a lot of time. You could almost finish it, or at least get a lot of it done if you work.
Are you recording in this class?
Yes, I am recording.
Oh.
All right. So what we're going to talk about today is local and absolute extrema. So what an extrema is a max or a min. It's the fancy word for max and mins. Mm-hmm. And if you think about it, it sounds like the word extreme, right? So that's kind of where it comes from. A maximum is when your graph is going to go from increasing to decreasing. A minimum is when your graph is going to go from decreasing to increasing. So if you kind of think about this, if you go from increasing to decreasing, it makes the mountain, right? Yep. So that would give you a maximum. Whereas if you go from decreasing to increasing, it makes kind of like the valley. Yes, the VU, whatever. But it would give you your minimum. Okay. When you're talking about maximums and minimums, you're talking about the lowest and the highest point. And so the y value is going to be the max or the min. Now, a lot of times we'll put the whole coordinate point, and on your homework, I want you to just get in the habit of putting the whole coordinate point because, and we're going to talk about this later, but sometimes it asks about where. Where is an x value? What is a y value? Right. So the y value would also be the minimum, bless you. The x value would be where it is located at. All right, so you got max and you have mins, very, very highest, very, very lowest. And we've got two different kinds of extrema. We have absolute and we have relative. All right, so the absolute extrema is the very highest point. So the relative are all the humps and the valleys. Does that make sense? So when you have lots of waves and stuff and you've got lots of humps and valleys, so like this, oh, that's a highlighter. So when you have something like this, you would have maximums here, here, and you'd have minimums here and here. Does that make sense? Okay. But when you're talking about absolute, I'm talking about the highest point on my graph, the lowest point on my graph. And so the big difference for relative and absolute is that absolute can also be endpoints. All right, another word for relative is local. If you hear the word local, that means the same thing. And another word for absolute is global. So don't get thrown by the vocab. I think in AP Calculus, relative and absolute are the most common, but sometimes you hear local and global. Okay, so let's start off with a problem. First of all, this G here is supposed to be colored in. That's my fault. Is it colored in on yours? No, it's not. No. Yeah. Okay. So we're going to start off with the absolute. All right, the absolute extrema. So on this graph here, what is the very, very highest point? G. What is the very, very lowest point? B. So absolute extrema is the very, very highest and the very, very lowest. Now, relative extrema is talking about all the humps and the valleys. So relative maxes are at the top of your hills. So it actually has to have a hump for it to be a relative. So just D. All right. So A doesn't count because A does not hump. So all of your relatives, they have to hump. Okay, what about the relative mins? Mm-hmm. B and F. All right, so B and F are both relative. Okay, so this one here is what I was talking about with the vocab, like where and what and X and Y and all of those good things. So your extrema, your max and your mins, they are going to be located at the x values, but the actual max and min is the y value, because the y value will tell you how high or how low your graph is. So if you were coming across a question and it was like the relative minimum is, and then it was like A, B, C, D, and they were just one single number, they're talking about the y value. What is the minimum value this graph is going to, or the maximum? If it says, where is there a max or min, then you're talking about the x value. So I just kind of want you to be aware of that vocab. If you want, you can just put the whole coordinate point and then cover both x and y. All right, but then we're talking like if it was a multiple choice question and it just gave you one specific number, pay attention to whether it's asking for where or what. Okay, so the relative minimum is, maximum, the relative maximum is what? But which one would be the maximum? 1, and it's at x equals 2. One of your relative minimums is -8, and it's at x equals -3. One of your other relative minimum is, and it's at 4. So I've seen those kind of questions asked occasionally like that, where it'll be a multiple choice, and it'll say the relative maximum is, and it'll be like A is 1, B is 2, C is -8, and they'll try to trick you by giving you the x value. But the max and the min is telling you how high or how low it's going, so it's a y value.
If there's arrows at the end of the line, then the minimum, the absolute minimum and or maximum would just be infinity, right?
Yes. Okay. Also, on your homework for today, you're going to have a calculator question where you're going to have to find the max and the min with the calculator like we did yesterday. This one, I think, does give you decimal points. Hold on. Okay, so you're going to go into your calculator and you're going to type your function in. X cubed minus 4x plus 1.
How did you get a calculator?
You're so fast. Did you run?
No, don't do. Let's say, can you give me a calculator? No, because over here is all this calculator. I'm gonna see Eric get up.
All right, then you're going to go to graph. And you need to be careful on your graphs. Don't assume they're at nice whole numbers. They are not always at nice whole numbers. All right, so you cannot assume that this one is at -1. It's actually not. It's a decimal. So what you have to do is you have to use your calculator to find that specific point. So we're going to go second, trace, maximum.
Yeah.
Move your little guy on the left side because it says left bound. So your calculator will tell you what to do. And then you hit enter and it's going to say right bound. So move it somewhere on the right side. Hit enter.
And it doesn't matter where we...
Just anywhere on the left and anywhere on the right. Yep. You don't want to go too far, but just on either side of your hump. And then enter for the guess, and it will pop up at the maximum point. So you should have these decimals on your calculator if you did it with me. Does anybody need help with the calculator right now? All right. If you get stuck when you're working, let me know. Sometimes it just takes a little one-on-one to fix some calculator skills. Especially if you're not used to these calculators. Okay, so you have to hit second trace first, and then go down and hit maximum. Yeah, and then it'll say left bound. So now move the arrow on the left, hit enter, and then move it over there on the right. Jump backwards, and yes.
Are we gonna round the numbers?
Yes. So good question. For the rounding, and this is to prepare you for AP Calculus, I want 3 numbers after the decimal. It doesn't matter if you round or not. So generally I tell people just go ahead and truncate, which means that on this one, I would put negative 1.154 and then just leave it alone. If you wanted to round and go negative 1.155, that is okay. But if you put negative 1.15, you're getting the question wrong. Okay? 3 numbers after the decimal. You can either round or truncate, but you need 3 numbers. So same thing on the other one, 4.079. You would write as 4.079. All right, second trace, and then we're going to do the same thing, but we're going to do the minimum. So I'm going to move my little guy over here to the left, move it over on the right side of the minimum, and then enter for the guess. And then same thing, you would either round or truncate those numbers, but you do need 3 numbers after the decimal. Yes, they do. All right, so the local maximum value, remember that's a y value. So that's going to be at 4.079. It occurs at x equals negative 1.154. No, you could just put negative 1.154. That's also, you could round, yep. And then the minimum value is negative 2.079. And that occurred at, and once again, you don't have to put x equals if you don't want to, 1.154. Okay, and then the last thing we're going to talk about here is boundedness. All right, boundedness. So boundedness has, it's kind of a similar idea to absolute extrema. But we're looking at the ends of my graph, and I want to know, are they going to go up or down forever? So on this very first one, are you going to go up forever? No, you're bounded above here. Are you going down forever? No, you're bounded below here. So this graph would be bounded because it's not going up or down forever. It is a bounded graph. Okay, on this next one, are you going up forever? Yes, because these arrows right here. Are you going down forever? No, so this one would be bounded below. Not bounded above, just bounded below. Because you're not going down forever. So if there's anything preventing it from going down forever or up forever, that would be a bounded graph. So this one here, we're going down forever, but we are bounded above. So we're bounded above. All right, and then my last one, which is a little tricky because we've got stuff going on in the middle of my graph. But I don't actually care about what's happening here in the middle of the graph. I care about if it's going to go up or down forever. So is this one going up forever?
Yeah.
Yes. Is it going down forever? Yes. And so this one would be not bounded. So I don't care about the fact that there's an asymptote here and my graph has vertical asymptotes as well. None of that matters for boundedness. It's just, is it going up or down forever? Okay, questions? Okay. Let's look at your homework for a second. All right, I'm going to do number 2 with you just so you can kind of get a little refresher for increasing and decreasing and extrema and how I want you to write your answers. All right, so we're going to start on my graph and we're going to start on the left. And are you increasing or decreasing? Decreasing from what to what?
0 to 4. Oh, sorry.
Negative 3 to 0. So from here to here, we're decreasing.
Yeah.
And remember, when you're doing your intervals, those are all x values. All right, and then we're going to do what? Increase from here to here, which is from
0 to 4.
0 to what?
4.
What?
4.
What?
2.
Because the x value. It does go up to 4, but you're doing x values when you're doing your intervals. So 0 to 2, we're going to increase, and then you're going to decrease from 2 to 4. All right, so increasing and decreasing, that's what we did yesterday. Now for the extrema. Let's do maxes first. Where do you have a relative maximum? So remember, maxes make the hump.
Relative.
Relative are the humps.
0, negative 1, 2, 3.
That's the min. Mm-hmm.
Whoops. 2 and 4.
Yes.
Oh, this one.
So 2, 4 is the maximum. That's right here. And the minimum is going to be at 0, negative 3. That's right here.
So, does it matter if they're open or closed on? Like,
Nope.
the bracket parentheses.
Nope. You'll just, because we're not talking about domain. All right, so I've got my relative max and I have my relative min. The relatives come from all of the humps. Now for your absolute, that is the very, very highest, the very, very lowest. What is the highest point this graph goes to? Negative 3, comma 5. Yeah. Negative 3, comma 5. So this point right here is the highest that point goes to. So that is the absolute maximum. What is the absolute minimum? 0, negative 3. So this guy right here is the lowest point the graph goes to. So your endpoints can be the absolute extrema. It doesn't mean it has to be, though. So this endpoint is nothing. It is just an endpoint. It is not the very lowest or the very highest, and because it's an endpoint, it's not relative. The relative extrema have to come from the humps or the valleys. All right? The max and the mins for the absolute are the very, very highest and the very, very lowest. If your graph has arrows and it's pointing upward, does it have an absolute max? No, so you can put infinity or you can put none, either one. I think I might have put infinity on my, or I might have just not wrote it.
And then if there's multiple, would you do like the U then?
You can just list them. Yep. So like on number 1, for absolute extrema, what is the absolute minimum on number 1? 3, negative 5.
What? Oh, negative.
All right, so right here is the absolute minimum. It's the lowest point it goes to. What's the absolute maximum? Infinity. Or you don't even have to write it because technically infinity doesn't exist. If you want to write infinity, you can. I don't think I wrote infinity on the key. So if it's missing something, it just means it's either going to infinity or negative infinity. Does that make sense? Mm-hmm. Okay, the rest of class you have to work, so you have a good 30 minutes to get this homework done. So you should make some progress on it.